Hello, everyone. Thank you for your coming, and thank Boulder and Andrew for holding this workshop. My name is Chengyi Lyu. I'm a PhD student at Boulder. And today, I'm very glad to share with you our work, assortment and price optimization under MNL model with price range effect. It's co-work with Stefanus Jasin from University of Michigan and my advisor, Huanan, from Boulder, and also Andrew from Oracle Labs. So this is the layout for today's presentation. First, I want to introduce the motivation of our project. So here, I want to give an example to introduce the motivation. So suppose that you are planning your Christmas vacation to the Kyoto, Japan. So Kyoto, Japan is a city in Japan, although it's not as famous as Tokyo, but it's a very good place to experience Japanese culture. So here, suppose that you are searching the hotels on the internet, and you have some information here. So you come across the first hotel, which is called the Good Nature Hotel, and its price is $200 per day. So if I only give this information, we'll decide to stay in the Good Nature Hotel or not. If you only have this information. Yeah, it's very difficult to say because you want to have more information and compare this hotel with others. So if you have more information, the second one, which is called Park Hotel, and its price is just $70 per day. Then what do you think about the $200? Do you think it's too high or too low, the $200? So compare with the Park Hotel, then maybe you think that the Good Nature Hotel is very expensive. And what's more, if you have more information, the third one, the Westin Kyoto, and its price is $500 per day, then what do you think about the Good Nature one? Will want to choose the Good Nature Hotel or not?
Do you know how to price?
Yeah. So after you see the third one, maybe you think that the $200 actually is not so expensive. And among these three hotels, the Good Nature Hotel, the price of the Good Nature Hotel actually is moderate. So maybe you will more likely to choose the Good Nature Hotel after you see the Westin Kyoto. So I use this example to illustrate that other prices in the assortment can affect customers' decisions. And what's more, typically when customers search the hotels on the internet, they have lots of choices. And in the previous example, we know that other prices in the assortment all affect the customer decisions. But when we build the model to describe the customer's behaviors, then if we include all other prices in our model, then our model will be very complex. And if we use such model, then we need lots of data to train our model and to estimate the parameters. So here, Volkmann introduced the range theory. It says that customers view the price of a product in terms of its relative position with respect to the highest price and the lowest price. So that means when the customers make their decisions, the highest price and the lowest price in the assortment are most influential. So in our project, we want to introduce the price range effect in the choice model, which is related to the highest price and the lowest price. And currently, we know that the standard MNL model doesn't consider the reference price effect. And the MNL model with the lowest price as the reference price has been studied by Professor Ruxian Wang. So in this project, we want to introduce a more general case. It's the MNL model with price range effect. So that is the background of our project. And then let me introduce what is the price range effect. So in the marketing literature, they use this linear expression to describe the price range effect. And here is equal to a negative constant times the relative position with respect to the highest price and the lowest price. So here the PI is the price that we focus on. And P-min is the lowest price in the assortment. P-max is the highest price in the assortment. And to better illustrate that, we use this figure here. And we can see that it's following the linear expression. And at the point P mean, its corresponding price range effect is 0. And at the point P max, the price range effect is equal to the negative lambda. And if we focus on a specific point, the price P, then we can use this formula to get its corresponding price range effect. But because we consider the assortment and the price optimization, so typically the highest price and the lowest price in the assortment can be changed. So if we change the highest price and the lowest price, we can see that even if at the same point, at the point P, its corresponding price range effect is also changed. So that means the highest price and the lowest price can affect all products in the assortment. So this property introduced some challenges in our project. So if we want to include the price range effect in the choice model, then the highest price and the lowest price are also our decisions. And specifically, for the assortment optimization, different assortments can have different highest price and lowest price. Then how should we find then how to find the structure of the optimal assortment? And for the price optimization, we show that the total expected profit is not jointly concave in the highest price and the lowest price. Then we want to ask. Then we want to answer how to decide the values of the highest price and the lowest price, and which item should have the highest price and the lowest price. And it's much more complex for the joint price and the assortment optimization. We need to simultaneously decide the prices and the assortment. We need to simultaneously decide the prices and assortment. So so these are some challenges in our project. And next, let me introduce our model. So in our model,
so if you could go back like 2 slides, the graph that you showed, I was thinking that the narrower one would have a larger effect. So it would have a smaller effect. So how do you think about then, for the same price, the narrower one having larger effect?
So is
go
this?
Back to the graph. So it seems like the narrower one has a larger effect.
Because its relative position to the highest price is more closer to the highest P max. So you feel that this product is becoming more expensive.
Yeah, so just intuitively I was thinking that in the wider one, the effect would be more pronounced. And that basically says maybe the relationship shouldn't be linear, right? But that's my intuition, so it may be wrong.
For wider one, you see that P is kind of like in the middle between P max and P min, so that give you kind of a moderate negative penalty for these products. But when in the more narrow one, you see that actually this P is more closer to the P max, so you feel that this product is more on the more expensive range, where you have a larger negative penalty.
It's not the absolute distance that equates the relative.
No, I understand. It's not obvious to me like which way this should go.
I mean, it's just, but ultimately it's just this like relative position that's important in this model. Yeah.
Okay, thank you, Huanan and Red, for answering these questions. And then let me continue the model description. So in our model, we consider several products, several items, and then we can get the expression of the expected utility of product I. And here the alpha I is the intrinsic value, and the negative beta times pi measures the price effect, and the third part is our price range effect. So here again, you can see that the lowest price and the highest price can affect the expected utility of any product in the assortment. And then follow the multinomial logging model, we can get the expression of the purchase probability of product I. And then we can express the expected total profit, which is equal to the summation of the markup of product I times the purchase probability of product I. And here the markup of product I is equal to the PI times CI. Is the price of product I minus its cost. So this is our model. Is there any question before I go to the main results? Okay, great. So then let me talk about our main results and see how we deal with these challenges we talked about before. So in this project, we consider 3 problems. The first one is the assortment optimization. So in this setting, we assume that the prices for all products has been determined by the marketing department, and what we want to do here is to find the optimal assortment. And we give one structure of the optimal assortment here. So under our model, there exists an optimal assortment that is central markup order. So the central markup order means that if we put all the items from the left to the right in the price decreasing order, then first we can find one item with price PM, put this item in the assortment and let it provide the highest price, and then find another one with price PN, then let it provide the lowest price. Then for all other products whose prices are within the PN and PM, we can find a threshold, and all the products whose markups are greater than this threshold should be put in the assortment. So if we know 3 terms, the highest price PM, the lowest price PN, and the markup threshold, we can have the optimal assortment. So with this property, it's very easy for us to find the optimal threshold.
Question, so if you can solve the one-shot assortment for your let's say some other choice model, then can't you always do the same thing? Like pick 2 products, one has the smallest price, the other one has the highest price, search over those 2, and then for the subset that their price is in the middle, solve the one-shot assortment.
Yeah, that makes sense. And so this is one structure for the optimal assortment, and we can, with this structure, it's very easy to find the optimal one. And the next one is price optimization. So here we assume that the prices for all products have been determined, and here we assume that the assortment is determined, and we want to decide the prices for all products. And here we prove that there exists an optimal pricing policy that is central theme markup. Then let me explain what is the central theme markup pricing policy. So to find the central theme markup pricing policy, we need to know 4 terms. The first is the item that provides the highest price, and also we need to know the values of the highest price and the lowest price, and also we need to know the value of a markup. Then let me explain, if we know these 4 terms, how can we find the prices for all products? So here we use the golden bar to represent the cost of each item, and the gray bar to represent the markup of each item. Then we put all the items in the cost decreasing order. And then we find the item and let this item to provide the highest price. And then we set the lowest price for this assortment. And after that, we add this markup to all the remaining products. And after this step, you may notice that for the second item and the third item, their prices are greater than the highest price. So we truncate their prices to the highest price. And for the last 2 terms whose prices are less than the lowest price, then we increase their prices to the lowest price. And after these steps, this assortment can be divided into 3 parts. And for the first part, they all have the same price, which is equal to the highest price. And in the central part, all the products have the same markup. And in the third part, they have the same price, the lowest price. So that is the central theme mark pricing policy. And about how to find these 4 terms, we mentioned that the total expected profit is not jointly concave in the highest price and the lowest price. So we introduced 2 approximation algorithms here, and we proved that these 2 algorithms are FPTAs, and we can use these 2 algorithms to help us find the near optimal solutions. But due to the time limitation, I will skip this part. And if you are interested in these two algorithms, we can talk about after the workshop.
Just a quick question. Is it just discretizing the set of the continuous prices?
Yeah, exactly, yes.
It's not just discretizing, we also have bisection search somehow.
Yeah, we have the bisection search, and within the bisection search.
Yeah, bisection is going to have linearly because you have 3 dimensions. Where if each dimension you do discretize, then it's like the runtime is going to be much slower than if you are able. Yeah.
I'm a computer scientist. I'm fine with putting.
Yeah.
And the third one, the third problems we consider is joint assortment and price optimization.
So I guess it just contradicts my intuition a little bit. Like you actually have multiple products, price is the highest price.
Yes.
You actually bring some of those up to the high price. It's counterintuitive because when you bring the price up, of course you have a higher margin, but a lot of time you actually suffer from this range effect. You've done a lot of numerical studies. Do you see, it happen or not? Like you actually bring the price up to the Tmax?
Yeah, actually, if we don't set the upper bound.
Let's bring down. Yeah, sorry. Let's bring down. But still, I find it a strength that you will have.
You're going to check other options for Pmax as well. So if there is one of them that can potentially contribute to your revenue is in the optimal assortment set, then in another choice of Pmax is going to be tested.
Okay, I guess it's just counterintuitive because it's the software.
And in the optimal assortment, this may not happen.
Right. That's correct.
That's good.
Yeah. So here we just need to describe how we can construct an optimal solution, and then we search for all those type of constructions and find the best one. But this characterization helps us speed up the search space. So, that's a very good question.
But in the optimal solution, it might be the case that we won't have this.
It is possible. Yeah, it is possible. Yeah. It depends on the cost of the original.
Okay, so let me continue the joint assortment and price optimization. So here we need to simultaneously decide the prices for all products and the assortment. So similar, we give structural properties here. We show that a central cost ordered assortment combined with the central same markup pricing policy is an optimal strategy. And we already introduced the central same markup pricing policy. Then let me introduce what is the central cost ordered assortment. So here we put all the products in the cost decreasing order. And then we find one item, let's this item to provide the highest price. And for the remaining items, we can find a threshold, and all the products whose costs are less than this threshold should be put in the assortment. And after that, we have this assortment, and we can directly apply the central same markup pricing policy to get the optimal strategy. So that is the structural property for the joint assortment and price optimization. And besides the structural properties we showed previously, we also did some numerical experiments here to justify our model. Here we use two real-world data sets. One is the hotel data set provided by Oracle Hospitality GBU, and the other one is a retail data set. And in our numerical experiments, we compare our model with the standard MNL model, and also the MNL model with the lowest price used as a reference price. So our numerical experiments includes two parts. First, we show the empirical performance of these three models, and we show the result of the AIC and the BIC, the two measures to show the goodness of fit. And here, the less value means the better performance. So you can see that among these three models, our model, the MNL model with price range effect, has the best performance. And the second part, we did the cross-validation. We use 80% of the data to train the model, and the remaining 20% of the data to test the prediction accuracy. And here we show the mean square error of the total profit and also the KL divergence. And similar here, the less value means the better performance. And we show that our model improved the prediction accuracy. So this is our numerical experiments. And finally, let me give the conclusion of our project. So in this project, we consider the MNL model with price range effect. And for the assortment optimization, we show that central markup order assortment is optimal. And for the price optimization, we show that there exists an optimal central theme markup pricing policy. And for the joint assortment and price optimization, we show a central cost order combined with a central theme markup pricing policy is an optimal strategy. And then besides that, we also introduced two approximation algorithms to help us get near optimal solutions. And we prove that these two algorithms are FPTAs. And also we use two real-world data sets to justify our model and show that our model improved the goodness of fit and the prediction accuracy. So that's all for my today's presentation. Is there any questions?
Yeah, quick question here. Basically here you consider the reference impact, effect like the P-max and the P-mean. P-max has positive impact on the product utility, and whereas the choice of probabilities, that's the opposite of P-mean. I have a crazy idea. While you consider optimization for assortment for pricing for the joint optimization, is it possible to create a fake product and the selling price is very high, like infinity, no one is going to buy it, but the utility for other product will be higher, and the choice of probability will be higher as well. And overall, the impact may be positive in terms of revenue profit.
Yeah, that's a very good point. And we consider it when we did our numerical experiments. And so here we test that if we don't give the upper bound of the price, then there is a product that always sets as the, the products. There is a product whose price is very high. So in our numerical test, we set the upper bound of the price. And when we give the structural properties and all the proofs, we also set the upper bound of the product price.
Yeah. At the same stage. When we consider price optimization, probably make more sense to consider the lower bound and upper bound for the prices. That's the case when we do this measure.
Yeah, this is more like kind of business practices, like
yeah.
this anecdote about $500 bottle wine.
Yeah.
Here we have sell like $100 bottle wine.
Yeah,
nobody
it's
buys
actually
that, but
yeah. And the actual measure we assume the price coefficient or price sensitivity is constant for all prices, but actually, if we do the piecewise and linear, and the sensitivity of the coefficient could be different in different price ranges.
And it's the thing, if you put one product with like really high prices, your optimal assortment is just going to be a single tone. So you don't want even another item to tangle with this one.
I see.
But it's your fake product, so you don't want that one to be displayed to the customer.
well, it may be real product, but you don't expect anybody to buy it.
Yeah,
It's
so-
sort of like one.
No, but if you run this
display.
algorithm, it's going to give you the optimal assortment to be done.
Yes.
Yeah, but it has a positive impact on other products. Yes.
Yes.
So that's why you're going to send our price upward.
Excuse me, Pat, if you see like a president suite that is $1 million per night, you think that's probably going to be just an error in the display, rather than really interpret that and apply that perception on other products. So maybe you still cap that maybe $1,000 or $2,000 per night.
There's also the customer perception of that, yeah. So we use reference pricing, so we're not upsell pricing. So a hotel may have a presidential suite and they may have an upsell price of $500 a night. They don't expect anybody to buy it, but it is well within what a user might expect to pay for a presidential suite, right? So they don't feel like they're being scammed or manipulated. So I think if a hotel said, we want to have it available, but we never want to sell it, so price it at $3,000 a night, well, the user perception of that is what are you doing here, right? And so there's that, also that psychological impact.
Yeah, there are some kind of like behavioral, right?
That's right.
Kind of like dimensions of this problem. And this price reference theory is a lot of like behavior, right? Kind of like aspects to Getman adversely. Yes. So time is up. Let's make our speaker.
Thank you.